Okay, so this question is around polymers and polymerization. The first one wants us to draw the structure of the polymer we would get from this monomer. So remember what you do is you split one of these bonds, one of the double bonds, and they stick out on the end of here. So when I do that over here, let's draw my two carbons now with a single bond, put my H's on, as there are there, two in each one, and then put those new bonds poking out of a bracket and N, because that is going to be repeated N times within the polymer. Next one wants me to draw the monomer unit. So remember, all we have to do in this one is we put these bonds back in to the middle to remake the double bond. So if I draw my two carbons now with a double bond and then put all the atoms attached as they are, so Cl and then a H, and that's done. And this one is name of the polymer. So this is called poly tetrafluoroethene. Tetrafluoroethene. Tetra because there's 1, 2, 3, 4 ethenes, and it's ethene because there's one carbon, two carbons in the structure. There's one mark for each of the answers we've put together. Problems of disposing of polymers. Number one is they are not biodegradable. So that means when we put them into the ground, they will not decompose, they will not break down. And that means that landfill sites will become full, and therefore we will run out of space to get rid of rubbish. Other thing we could put in there, just a few different options, but one of the things that we talked about is if we burn them, then it causes toxic gases to be released. So burning causes toxic gases to be released. So we wouldn't want that either as a problem. You need two, so just pick any of those two and you're good to go. Okay, here's a molecule of propene. Which of these would be poly? So many propenes. So remember, all we do is we split this bond here and attach this out and just keep repeating that unit again and again and again. So if we look at what we have got down here, the unit that's repeating is this unit, and that unit, it doesn't mirror the one we've got here, so that's not correct. This one does, so there's a unit, and then there's another unit, so that one is definitely looking good. This one's not right because there's two CH3s here, and this structure's only got one CH3 on the end, and this one's not right because it's got 1, 2, 3, 4 CH3s, so that's not right, that's not right. This is the wrong way around, so it's option B is the correct answer. Okay, next one here is calculate the relative formula mass of polypropene joining together this big number of molecules. So all we've got to do here, we're joining together 24,600, and the mass of one of them is 42. So all I'm going to do is put 24,600 times by 42, and that's going to give me 103,3200 as a relative formula mass. Be careful because it wants an answer to three significant figures. So what I'm going to do here is go 1, 2, 3. Let's look at the fourth. The fourth one is less than 5, so that's going to become 103 and then 0000 to get the marks for this. So there's one mark for multiplying that by that and one mark for getting your answer in the right number of significant figures.